When it comes to our food, we're really talking about glyphosate because that's the entity that's systemic in the plant, moves throughout the plant, and then accumulates in the parts of the plant that we normally consume. Those are the growth points, the seed and reproductive structures, and the root tissues. So, for potatoes or carrots or cassava, any of those root crops, we're going to have an accumulation of glyphosate in them, but not the surfactant.
You're listening to Food Integrity Now with your host, Carol Grieve.
Hello and welcome to Food Integrity Now. I'm Carol Grieve. I am a certified holistic nutritionist and the host of the show. At Food Integrity Now, we like to investigate and explore what's happening in our food supply so that you can make wise decisions for your health and for your family's health. And I'd like to give a big shout out to Ben Sound Music for our intro and outro music. I am honored to have as my guest today Dr. Don Huber. Dr. Huber is a professor emeritus of plant pathology at Purdue University and is a graduate of the U.S. Army Command and General Staff College and Industrial College of the Armed Forces. He was serial pathologist at the University of Idaho for 8 years before joining the Department of Botany and Plant Pathology at Purdue University in 1971. His agricultural research the past 60 years has focused on the epidemiology and control of soil-borne plant pathogens. He retired in 1995 as Associate Director of the Armed Forces Medical Intelligence Center as a colonel, after 41 years of active and reserve military duty. He is an active scientific reviewer, consultant to academia, industry, and government, and international research cooperative with projects in 11 countries as well as in the U.S. He is the author or co-author of over 300 journal articles. Today we're going to be talking with him about the latest information about GMOs and glyphosate. Hi, it's Carol Grieve, and I am a certified holistic nutritionist, a life coach, and the host of Food Integrity Now. What you eat and how you eat can greatly affect the way you look and feel, and whether or not you get sick. If your immune system is compromised, you might have brain fog, allergies, low energy, depression, or worse, have a disease. A poor diet can lead to diabetes, cancer, Alzheimer's, and virtually all other diseases. I take great pride in working with individuals and groups and seeing how they create such positive changes in their lives. I offer one-on-one coaching packages, or we can design a package just for your group. To find out more, go to foodintegritycoaching.com or call me at 415-302-7100 for your free consultation. I offer phone and Skype sessions, and this really is all about quality of life. Let me assist you to have the best quality ever. Hi, it's Carol again. Do you drink almond milk? Do you know that packaged almond milk contains all sort of nasty additives like carrageenan and barely contains any actual almonds? The good news is that you can make fresh almond milk at home in minutes. Once you taste the creamy, fresh flavor of homemade almond milk, you'll never go back. I make my almond milk at home with a Nutiana nut milk bag. It's great, easy to use, easy to clean, and makes my almond milk silky smooth. Buy yours today by searching the Nutiana nut milk bag on Amazon. That's Nutiana, nut milk bag. Or go to Nutiana.com. You're going to love this bag. Dr. Huber, welcome to Food Integrity Now.
Well, thanks, Carol. I appreciate the opportunity to visit with you.
We're honored to have you on the show, and I think we last spoke about 3 years ago. And I know that you and others have been doing more research, and there's a lot more information about the effects of GMOs and glyphosate on not only our soil, but plants, animals, and humans. Let's step back a little bit and recap some of the information for our listeners about glyphosate, which is, as we know, is the active ingredient in Roundup. One of the things that is so important, there's so much information right now about the importance of having a healthy microbiome or having a healthy gut, especially for brain health. So let's talk a little bit about some of the ill effects of glyphosate on soil organisms, which of course are not that much different than the microflora in our gut. So let's start there.
Well, glyphosate is a patented antibiotic. Most people don't realize that, but it's quite a wide spectrum antibiotic that also has been shown to induce antibiotic resistance or resistance in organisms to a number of our other regularly used antibiotics. So because of its broad spectrum activity, it also has the ability to induce resistance in a lot of our pathogens to our common antibiotics, as well as being an antibiotic in its own characteristics, but it's an antibiotic against the beneficial organisms rather than against the pathogens, so that it stimulates the pathogens by increasing their virulence, their ability to cause disease, and also suppressing a lot of the natural defense mechanisms that animals and plants have, or that we have in the soil with other organisms that would suppress the pathogens. So it's just a very unique chemical in its broad spectrum activity and extensive damage to the environment.
Well, we also know that glyphosate is a mineral chelator. Can you recap a little bit about what that means?
Yes, a chelator is a chemical that can grab onto another element and change its characteristics. So some chelators can be very beneficial, and we use those, EDTA and a number of other chelators like citric acid or malic acid. But glyphosate, again, when it grabs onto a mineral element, it immobilizes it so that it's no longer physiologically available for use in an animal or human. And you have a mineral deficiency then that is induced, even though the mineral may be present. When it's bound with the glyphosate, physiologically it can no longer function in those critical physiological areas for enzyme action or protein activity. So we see a lot of mineral deficiency now, even though there appears to be plenty of minerals available, but if it's chelated with the glyphosate, which many of them are, they're not physiologically available to do us any good. They're just chunks of gravel sitting around in our digestive tract or in the environment for us.
I know one of those minerals is manganese. What could happen if we're deficient in, say, manganese?
Well, manganese is involved in over 28 enzymes as the key, that cofactor that turns the enzyme on or off, that regulates it. When we're deficient in manganese, and you see a deficiency in hormone systems and in a plant and photosynthesis, so that you see yellowing and those characteristics. But all of the minerals are involved in critical physiological functions as cofactors for different enzymes. In fact, that's how glyphosate works as a herbicide, as a weed killer, is by tying up critical minerals that are involved in those physiological processes. We talk about the shikimate pathway and other physiological processes, but it's actually the chelation or the immobilization of the cobalt or manganese, iron, or other elements that it is immobilizing that are responsible for that shutdown of physiological activity. And manganese is one that's very actively immobilized by glyphosate.
Okay, and we also know that glyphosate blocks the C1 metabolism, and why is that a concern?
C1 metabolism is involved in detoxification of the body. That's how you get rid of formaldehyde and other natural toxins that are produced during the physiological process. When you block C1 metabolism, then formaldehyde accumulates, and as the formaldehyde accumulates, it depletes the glutathione. The physiology, the body responds to the formaldehyde by reacting with glutathione as an antioxidant, and when with the accumulation of formaldehyde, then glutathione is depleted. Well, that's our immune system, or a big chunk of it. So that you essentially have an induced immune deficiency type disease then that develops because you can no longer produce or maintain your glutathione defense function there.
Wow, that's amazing. And as many of us know, that glutathione is just a really powerful antioxidant and very important for our immune system. So if it's depleting the glutathione, that's a big problem.
It's not just the depletion that's involved, but the regeneration is also blocked.
What do you mean by that? Can you speak more about that, Dr. Huber?
Well, when glutathione is involved in those physiological processes of defense, that then it will normally be restored to your body will make more glutathione, and it'll continue in that function. With glyphosate, that is blocked, and also the GMO crops. When you disrupt the integrity of the genetic code, whether it's from insertion or whether it's from deletion or silencing, again, that C1 metabolism is a common pathway that is blocked, and that depletes the glutathione because of the increase in formaldehyde. But the glutathione then is not regenerated because those systems also are blocked.
Okay, and so the whole issue of glyphosate is just not only wreaking havoc on the health of our soil and plants and animals, but on human health, and especially in our gut. Considering that all the latest information, how having a healthy gut is really important to having a healthy brain. I mean, this is even more detrimental than we initially thought.
Yes, our immunity, our brain function, all of those things start in our stomach or in our GI tract.
Yeah. And
that microbiome that we have in our GI tract is critical to our hormone levels, our neurological chemicals, our immunity. That whole process all starts there and is maintained there, so that the organisms that are responsible for that, for those critical functions, are all very sensitive to glyphosate. They're also those organisms that suppress the pathogenic Clostridia and E. coli and Salmonella and Listeria. All of those pathogens then are resistant to glyphosate, so that when you take out large groups of beneficial organisms, the pathogens then have an opportunity to fill the void. In nature, we don't have voids, so when you take one group out, another group, in this case the pathogens, are able to colonize, and so we see the diseases like chronic botulism or chronic fatigue in humans, leaky gut, irritated bowel syndrome. All of those diseases are a result of changing that biological balance in the gut microbiome. So we have what we call gut dysbiosis, that imbalance in our microbial flora in our GI tract that then results in these very serious diseases that would normally be no problem for us if we had a healthy gut. And of course, you can have a fecal transplant, or you that can provide those organisms, but again, you need to change the cause to start with. And glyphosate residues in our food and in our water and environment as an antibiotic are very damaging to that gut microbiome.
And I liked what you said about going to the cause. And I'm a nutritionist, and the first place I start with people is strongly suggest they heal their gut and then eat organic food, so they don't keep that glyphosate going in their body. And I know it's hard to avoid because there's so much contamination, but eating an organic diet certainly is a great place to start.
Makes a difference.
Yeah. So one of the things that we're learning about is how glyphosate works with surfactants and adjuvants. Can you comment about the recent claims by some that the surfactants are worse than the glyphosate? Do you agree with that, or can you explain a little bit about how that works?
Yeah, I think we need to put that in perspective. There's no question that the surfactants and other additives can be more toxic than the active ingredient. But that would be a situation where you're for the pesticide applicator, or where it's dumped into the water source, and glyphosate is dumped into a lot of our ponds and streams as a aquatic weed control mechanism. That would be where you would see the residue from the surfactants. And that in food, the surfactants don't penetrate into the plant any significant level, and they would be washed off in the processing of most food products. It's the glyphosate that is systemic, so that you'll have the surfactants in some environmental situations, such as where it's used for aquatic weed control in rivers and streams. But in food products, it's glyphosate that is the concern, because the surfactants aren't in the product, but glyphosate is systemic, moves throughout the plant, and accumulates in the plant where the surfactants don't. Depends on what the exposure level is.
So let me see if I understand this correctly, because I really want to learn about this. Basically, the surfactants and adjuvants can make the delivery of the glyphosate into the plant or the body to make it stronger, but you don't actually get the effects of the surfactants and adjuvants into the food, but it makes the glyphosate more potent. Is that accurate?
Right. Okay. They're mixed with the spray solution with the glyphosate so that you reduce surface tension on the leaf, you get better spreadability, or for sticking the chemical on the leaf to permit absorption over a longer period of time, or to damage the leaf surface. Most of the adjuvants and surfactants that are used with glyphosate are also used in many other products, so we have a lot of exposure to the surfactants because there are a lot of places where you want to have, reduce the water tension and have smooth flowability. A lot of our cosmetics and soaps and detergents will have the similar surfactants to what is used in our pesticides, so that there are other sources of exposure to the surfactants than just glyphosate. Almost any pesticide, but also many cosmetics and dishwashing compounds, and those things are really surfactants. And we have additional exposure level to the surfactants, but when it comes to our food, we're really talking about glyphosate, because that's the entity that is systemic in the plant, moves throughout the plant, and then accumulates in the parts of the plant that we normally consume. Those are the growth points, the seed and reproductive structures, and the root tissues. So, for potatoes or carrots or cassava, any of those root crops, we're going to have an accumulation of glyphosate in them, but not the surfactant. The surfactant might be on leafy vegetables right after it's drifted on. If it was used as a drift, on an adjacent field or something, there might be a little drift. But again, the primary toxin that we're concerned about is this strong mineral chelator and antibiotic that we refer to as glyphosate.
Okay, thanks for clearing that up, because I think there's been a little bit of misinformation out there about the surfactants and adjuvants, and that makes a lot of sense. So there's also a lot of new information about chronic wasting disease in wildlife that we believe is connected to glyphosate use after glyphosate is used as a pre-harvest desiccant, which is a drying agent. Can you talk a little bit about that, Dr. Huber?
Well, when it's used as a desiccant, you could have, and especially deer and elk, come in and graze on those plants that have been sprayed very recently. There you have the glyphosate in a high concentration and right on the tissue that's being grazed on. So we don't really understand the mode of action of either the formation or the transmission of the prion-type diseases. This would be chronic wasting disease in deer and elk, or mad cow disease, the VSE, or the variant Creutzfeldt-Jakob disease. We have some hypotheses that that we work with and work from. Some of those aren't always consistent with the science that's being developed now. It's been thought that just the folded protein acts as an infectious agent, the normal protein being folded because of some abnormal or some change in the environment, and that then you have an infectious entity that's able to replicate and also cause other proteins to become infectious. There are two other hypotheses that fit the data a little closer than just that spontaneous generation that's commonly thought of, and one of them is Dr. Purdue's research on mad cow disease in England. He had an untimely death, so his research hasn't been pursued extensively, but what he showed was that when organic phosphate compounds, such as the insecticide that was used for warble grub control and poured right down the spine of an animal, that was a very strong mineral chelator, and that it brought about a change in the metalloprotein portion of the protein, the metallic part, which in the brain is copper. And the copper then would be chelated by the phosmet insecticide and replaced by manganese. In that replacement, then, you had a much stronger molecular pull on the protein, and it distorted its shape, caused the folding, and then self-replication from that point on. That work is supported by a number of other studies. It's not fully accepted, and the other hypothesis or proposal for formation of prions is spiroplasma, cell wall-free bacterium that can also cause the protein folding and disruption there.
What do you mean by protein folding? Our listeners may want to understand this a little bit more fully, as do I.
We have the normal protein. The protein function is related to the morphology of the protein. In other words, how it interacts from a molecular standpoint. And what happens then, you also, with those proteins, you have a metallic part of that protein that is, we refer to them as cofactors and transition elements, and depending on which protein it might be with, whether it's an enzyme or a brain protein, and that. But it's the mineral element that gives the protein its stability and that activates or regulates its function. So that when you change the metallic part of that, the mineral part of that protein, then you also change the morphology or the configuration of the protein. So copper, you would have those protein bundles or protein filaments in the brain that are pretty much standing up on end, or they can interact effectively then physiologically. And when you change the copper with manganese, then you have a much greater molecular pull or interaction of the mineral with the actual protein part, and so it distorts the shape of the protein. And it's that distortion then that changes its function. If you have a magnet and put it against some iron filings, you'll notice how the filings kind of stick up.
Yes.
As they are attracted to the metal. Well, like having different forces of magnet that would change the shape of those filaments as they're interacting there with the magnet. I don't know whether that's a good analogy or not.
I got a good visual on that. And why is that problematic then?
Okay, it's because it's that morphology of the protein that controls its function. And when you change the physical structure or the morphology of the protein, you also change its ability then to interact with those other elements that it is involved in from a physiological standpoint, whether it's an enzyme or whether it's a brain protein or other types of proteins there. It's that morphology that's important. And what the chelators do then is, and glyphosate would be very similar. It's a sister compound in some respects to phosmet, that the chelators then, because of their attraction and different strengths to different elements, they can bring about the exchange of the metallic part of that metalloprotein, and in that process and change the physical structure. So Purdue's concept was that you have this very strong mineral chelator, goes right down the spine, it's systemic, absorbed into the body of the animal, moves to the brain, especially where you're pouring it right down the spine of the animal, a cow or that, moves into the brain, where then it has a stability constant that's about 100 times greater for copper than it is for manganese, very similar to glyphosate, so that you see that exchange then that distorts the shape of the protein and also its function. When you distort the shape, you change the function, and it's that changed shape and function that gives it its ability to self-replicate and to be resistant to heat and to other proteolytic enzymes and many of the other common things that would destroy a regular protein, then a prion is resistant to. Don't know whether that explains it very well, but it
explains it somewhat to me, but the overall thing is it doesn't sound good. Doesn't sound like it's something we want.
We're still struggling to fully understand it, so we're working from from hypotheses. From the bacterial standpoint, the concept is that this is really an infectious entity that is really triggering that whole change in morphology of the protein.
saw something in the news just recently that the EPA is considering allowing thiomethazam, which is a neonicotinoid, to be sprayed on about 165 million acres. What can you tell us about that?
Well, in general, we're in the class organic phosphate. Most of those are endocrine hormone disrupting chemicals, and any exposure to it isn't a good thing physiologically for us. Should be zero tolerance for any endocrine hormone disruptor, whether it's glyphosate or any of the other compounds there. So depends on how it's used, its extent of use, and what the exposure levels are. But any exposure to an endocrine hormone disrupting chemical is going to be very damaging from a developmental standpoint of most organisms.
Yeah. One of the areas that I'm a little bit confused about, and maybe you can share some of your expertise, is about the CRISPR technology. Proponents claim it's safe and predictable, and it doesn't need to be regulated. Do you have any thoughts about that technology?
Well, most of the genetic engineering type technologies that we're using are based on fossil science to start with. Mm-hmm. Our understanding of how genes work is really primitive. And so we're doing a lot of things. We know how to do things, how to disrupt the system. We don't really understand what we're doing in that whole process because we only look for certain things. And CRISPR, whether it is just a gene silencing process, but it doesn't matter whether you're inserting or whether you're removing, editing, you're deleting genetic material. Our current concept of genetics is that it's a matter of the spatial relationship of the different nucleic acid components, and the protein entities. It's the spatial relationship that's interacting with the environment that determines what the function is. So that when we sequenced the human genome 50 years ago, we had anticipated 100,000 genes in the human genome, because we know we have more than that functions, and our concept of genetics at the time was one gene controls one function. Well, we know that's not the case now, because when the sequencing was complete, we only had about 20,000, not well over 100,000 genes in our human genome. And so we had to abandon that concept of one gene, one function. Well, that genetic engineering, whether it's CRISPR or gene editing or whether it's insertion, is still based upon that one gene, one concept, or one function concept, but that's not the way it works. It works by one gene may have literally 100 functions, and it depends on the environment and its relationship to other genes that are going to determine what that particular function is. So that with all of these genetic processes, when you disrupt the integrity of the genetic code, you have many mutations and many changes in function that take place. We don't look for those. To start with, we don't even know what to look for in most cases, because a lot of these new proteins that are produced have never been seen before. They're new to science. And a good example of that being a very serious problem was, as Steve Drucker points out in his book called A Gene's Twisted Truth, that when they genetically engineered the bacteria to increase the production of the nutrient L-tryptophan, that one of the side effects of that increased production turned out to be a fatal toxin or a fatal protein that was produced, the phenylalanine diamide, that was in minute quantities as a contaminant in the L-tryptophan nutrient supplement. But within 2 weeks after commercialization, 80 people were dead from anaphylactic shock, and they estimate now that up to 10,000 people are permanently incapacitated, even though that was pulled from the market. Well, you can imagine what the damage is from the chronic toxicity in contrast to what we saw with the L-tryptophan, with an acute toxicity, so it showed up almost instantaneously from the anaphylactic shock. But it takes 30 or 40 or 50 years for chronic toxicity to show up, so we have no idea what's down the road for us with a lot of these new proteins, because they're not tested, they're not studied, are not even recognized as being produced from that alteration of the genetic code. So CRISPR fits in that same disruption, even though it's a silencing, or they call it an editing type process rather than an insertion. It still changes that spatial relationship as it's influenced by the environment.
So, in my layman terms, the CRISPR technology could have random effects on our genes. In essence, it could turn one gene off and turn an unintended gene on that we may not want to be turned on. Is that accurate?
Yes, no question. In fact, that's been demonstrated. And some of those genes that it turns off are very critical genes for us, even though they may turn off a function in a plant. That CRISPR effect is going to be functioning and picked up in the digestive process by both our microbiome as well as even our own genetic code, or that we have those enzymes in our own genetic, not the enzymes, but that genetic system in our own genetics that can also be turned off with that technology.
I want to go back to glyphosate and just say I have two more questions about this. When we spoke, I think the first time we spoke was in like 2011 or 12, and I asked you a question about DDT, which we know has been banned. And do you still feel that glyphosate is more of a problem than DDT ever was?
Oh, they're not even in the same ballpark. DDT was used to reduce disease. Glyphosate, by its nature and function, increases disease. So that they're two opposite poles from a function standpoint. Glyphosate has a similar residual life to DDT, about 20 years in many of our situations. So there are a lot of similarities in some of those areas, but as far as toxicity, both chronic and direct toxicity and environmental impact, glyphosate is much more extensive and much more damaging than DDT.
Yeah, and it's so interesting because pretty much everybody you speak with knows about DDT, but I can't tell you how many times I'll mention something about glyphosate and people have never heard of it still, which...
well, you tell the lie often enough and it starts to be believed. And we've been told it's so safe all the time, and that, the only living things that don't have the shikimate pathway are mammals. So we were told it can never be toxic to us. But the problem is all of our GI organisms that we rely on for health and immunity and defense are all very sensitive to glyphosate. And they all have the shikimate pathway.
Yeah. And my last question about glyphosate is, in your opinion, what do you think is one of the best ways to detoxify your body from glyphosate?
Well, glyphosate, to start with, accumulates in the brain, in the bones, bone marrow, and then in liver, heart, tissue, and all of your tissues in your body. But its highest accumulations in the brain, next in the bones and bone marrow, and then in the liver, kidney, and other organs. So that it's been bioaccumulating in a lot of us for 30, 35 years. But getting rid of it's another story, and there are several things that the research is showing now. Dr. Monica Kruger showed that humic acid, or the humates, and fulvates were able to remove a lot of glyphosate. Dr. Dana Stanley in Australia is showing also tremendous benefits from the humic acids and clinoptilolite, a zeolite form that has the ability to change that microbiome into a more beneficial environment and remove glyphosate in the process. Those are the general approaches that are showing promise now. With all of them, when you remove the glyphosate, you're also removing a lot of your essential minerals, so you need to be taking a good mineral supplement if you're taking the humic acid or fulvic or clinoptilolite materials then to essentially detoxify.
I didn't understand that one word you just used, that clomophyllotite. I've never heard that word. Can you spell that for me?
It's CLINOPTILITE.
Okay.
Clinoptilolite.
Okay.
It's a form of zeolite.
Okay.
Now, there are 82 or more forms of zeolite, and you need to be careful with a lot of those because when they're ground down to a functional, none of them are really soluble, but when you grind them down into a functional relationship where they're in that entrapment mode, you can have a fiber effect similar to asbestos. The clinoptilolite maintains its tetrahedron structure so that it's able to grab on or to entrap the glyphosate without having the fiber structure. So what it is essentially a ground-up crystal, but it maintains the structure of the material but by grinding you get a tremendous increase in its absorptive capacity. So most of it today is used in pet litter or cat litter and that type of thing, because it can absorb ammonia and other materials. And glyphosate is a synthetic amino acid, glycine, then can be entrapped by the clinoptilolite, and then it's passed out through the feces.
Oh, wow. And I think at one point we were talking and you mentioned a product, and I think it was called Zeolite AV.
Okay. That's clinoptilolite with a little humic acid.
Okay.
In Europe, they market a product called Activamin. The V is a check mark, and brand name, I think that's primarily humic and fulvic acids in that, just a little capsule that you can take, and that...
and what's that called again? Active what?
Activamin. So I don't know how that translates into English. That's the German.
Okay, Activamin. Okay.
I believe that's the name.
And they're using it somewhat over there to detoxify from glyphosate. Is that what?
Right.
Okay. I'll have to find out about that.
It's a commercial product.
Okay.
I think there's some research I know going on here with the fulvic acids that in clinical trials that looks very promising.
Okay.
Sauerkraut juice, raw sauerkraut juice is with activated carbon. The activated carbon alone hasn't shown much response, but with in combination with raw sauerkraut juice has also been shown to both help gut microbiome restabilize, as well as remove some glyphosate from the body.
Well, that's easy enough to do. Sauerkraut juice. You can go to the grocery store and buy that.
Well, except when they pasteurize it, they take out the probiotic aspect that's probably involved in that. But the lactobacillus, bifidobacteria, and other organisms that are in that fermentive process are very beneficial to our gut microbiome. And those are the organisms that glyphosate is so toxic to. So it gives an opportunity from a probiotic standpoint, at least, to regenerate as long as you change your diet.
Right, yeah.
You're going to keep treating them to glyphosate, they don't last too long. That's one of the problems with a fecal transplant for irritated bowel or autism or any of those other 16 diseases, that it's a cure for, if you get the right donor, that you have to change your diet so that you don't keep killing it off.
Right. It's not a quick fix, that's for sure.
Yeah.
Well, Dr. Huber, this information has just been wonderful today, as always, and I know you're doing ongoing research along with others, and we appreciate all the great work you're doing to assist us and humanity. So thank you for being a guest on our show. It's always just such a privilege to speak with you.
Well, thanks, Carol. Keep up the good work there. We need all the help we can get with the onslaught of these chemicals that we keep dumping in the environment, and the ones that are really suffering are this young generation that's coming along. You look at their health status, and it's an atrocity from what it should be.
Yeah,
and
I totally agree, and that's why the education is so important.
I was happy to see Dr. Michelle Perrow's book in print on what's making our children sick.
Yes, I interviewed her about a month ago, and what a wonderful book. I think every parent, and actually probably every pediatrician or doctor, needs to read that book.
Yeah, very well done and tremendous help there.
Yeah. Yeah, there's a lot of people that, are assisting and getting the information out, and you're one of the big ones. So thank you again for being a guest on Food Integrity Now, and thank you to our listeners. We'll be back with another new show in a week or so. So thanks again.